All right, let's just make sure that we have our brains wrapped around this whole limit process. We're going to evaluate some function values, some left and right hand limits, and then overall limits. So the first thing that they ask us to do with this function is to evaluate f of -3. Remember, this is an old school pre-calculus question, just asking us what is the y coordinate when x is equal to -3. So when x is equal to -3, I go up until I hit the actual y coordinate, and that's a y coordinate of 1. So f of -3 is equal to 1. And then they ask us to evaluate the left and the right hand limits at x equals -3. Okay, so I'm going to draw my limit screen here, pull the curtain down. So we're not looking at all that stuff that's going on at x equals -3. We're just going to say what's happening from the left and what's happening from the right. So with the little negative superscript here, this is telling us just to look at the left-hand side of -3. So as I'm traveling along the graph, just on the left-hand side, what does it look like the y coordinate's going to be from the left? And that looks like it's headed to a y coordinate of 2. So the left-hand limit is equal to 2. Next up, they ask us to find the limit as x approaches -3 from the right. All right, so this time we're going to go, let's do this in a different color. We're going to go from the right-hand side. Right, so I'm going to travel along my function from the right-hand side. And from the right-hand side, just looking at the right-hand side of x equals -3, it looks like the y coordinate is also going to be a 2. So we're going to say that the right-hand limit at -3 is equal to 2. The last thing they ask us to do is to evaluate that overall limit. So they're asking us for the limit as x approaches -3. And notice that I don't have a little superscript from the left or from the right. So that's just talking overall, what is this function doing as it's headed towards x equals -3? And because the left and the right-hand limits agree, so these are equal to each other, that means that the overall limit at -3 is going to be equal to 2. All right, let's stick with the same function and do some other limits. So now we're going to focus on the same function, but this time at -1. All right, so the first thing is evaluate f of -1. So I go over to x equals -1, and I'm looking for the place where I hit a y coordinate. And I don't hit one at y equals 3. That's an open circle. I would just pass right through there. Same thing at 4.5. I don't pass through anything. I can keep looking forever. It doesn't indicate that I've got anything going on this function at -1. So we're going to say that f of -1 does not exist, or is undefined. Either one of those mean the same thing. All right, so then we talk about the limit. So now we're going to cover up the fact that we have those two open circles at -1. We're just going to ignore those and say, what does it look like this function is doing on the left-hand side and the right-hand side? All right, so on part F, it says as x approaches -1 from the left. So we're going from the left. So I'm coming along the function. Just as I get very, very close to -1, just from the very left-hand side, it looks like the y coordinate is going to be a 3. So the left-hand limit is equal to 3. All right, and then we do the right-hand limit. The limit as x approaches -1 from the right-hand side. So as I get close to -1, but now I'm traveling along that sort of parabola-looking part from the right-hand side, and I'm saying, what does it look like the y coordinate is going to be? And my best guess is going to be about 4.5. So I'm going to say 4.5. And that is our limit from the right, because I have that little positive superscript above the -1. All right, so then when they ask us in part H to find the limit as x approaches -1, they're no longer asking for one side of -1. They want us to take them both together. And my left-hand limit and my right-hand limit were not equal to each other this time. So when the left-hand limit does not equal the right-hand limit, the overall limit does not exist. So we're going to say the limit does not exist, or is undefined, either way. All right, we'll kind of think a little bit backwards this time. You might recognize this graph from when we were last together in class. This is f of x, and the first question we're asked is, for what values of a does f of a not exist? So they're looking for x coordinates where you get no function value. So we have all kinds of places where we do get y values, like at -6, at -4.2, we get y coordinates. Even at -3, where there's a jump in the graph, we get that f of -3 is equal to +1. And then we have y coordinates all over the place. At x equals 2 Yeah, I'm actually missing a y coordinate there, right? That open circle means there's no point there and there's no point floating above or below to indicate what the y coordinate is. So we're going to say f of a does not exist at x equals 2. And then just kind of examine the rest of the graph. Let's see, it looks like I have solid line, all of these points here are going to have y coordinates. Even at x equals 6, there's a hole punched in the graph, but right above it, I get that f of 6 is equal to 2. So that function value exists. And then we've got this line going off to the right forever. We're always going to have y coordinates associated with that. So I think x equals 2 is the only place where we don't have a function value for f of x. All right, so let me clean off this slide and then we'll answer the second question. All right, so our second question says, for which values of a does the limit as x approaches a of f of x not exist? So when we were looking at function values, we said at x equals 2, we don't have a function value because there's no y coordinate colored in up above x equals 2. But the limit at x equals 2 actually exists, right? So if I cover up what goes on at x equals 2, we cover up that hole that's punched in the graph and it looks like you're headed for a y coordinate of 3. The limit at x equals 2 is equal to 3. It actually does exist. Same over at x equals 6, where there's other kind of strange things going on. If I cover up that one, that limit exists, right? The limit as x approaches 6 is that v value down at the bottom at -1. So the limit does exist there. The place where we don't have a limit is over here at -3. So if I cover up at -3, from the left-hand side, my left-hand limit is equal to +1. From the right-hand side, my limit looks like it's equal to +2. So since the left-hand side and the right-hand side are not in agreement, we're going to say that the limit at x equals -3 does not exist. All of the other places on this function, the limit is going to exist. So if you pick this sort of mundane spot, like over at 9, where the function value is equal to 2, there, if I cover up what's going on at 9, then the limit is just equal to whatever the function value is equal to. All right, so that's it for the videos today. Make sure you took some good notes so you're ready for the quiz at the start of class, and I'll see you there.